This is the Algebra 1 4.4 video notes. So today we're talking about scatter plots and creating lines of fit. So the first thing we need to know, a scatter plot is a graph that shows the relationship between two data sets. Okay, and we're also going to write about correlation. The correlation is the relationship between two data sets. Sometimes they have a correlation, sometimes they don't, sometimes it's strong, sometimes it's medium. And then the line of fit is a line that is drawn on a scatter plot that is close to most of the data points. May not go through all of them, but it's kind of in general in the middle of all of them. Okay, if you need to pause so you can copy those down, go ahead and do so now. All right, interpreting a scatter plot is pretty easy, especially if you just pay attention to the variables. So it says X is the grams of sugar. We see that up here in the description, but we also see it down here on the label of the x-axis. We know X is the sugar, how many grams. Y is the number of calories. We see that on the y-axis, or we see it here in the description. And this is of 10 different smoothies plotted on this graph. So it says, how many calories are in the smoothie that contains 56 grams of sugar? So if it's 56 grams of sugar, sugar is X, so you know X is 56. So you go down to the x-axis, and like here's 54 and here's 58, so halfway between is 56. You go look to find the point that has an X value of 56. That's this point right here. And so basically what I'm doing is I'm just following it. I'm like, okay, well, here's 56. So I follow it to the left and I find out that the Y value is 270. So a smoothie with 56 grams of sugar has 270 calories. This says how many grams of sugar are in a smoothie that contains 320 calories. Well, calories Y, so it means in this one, you know Y is 320. So you go and you look for a point that has a Y value of 320. And we just see that it's this point right here. And so then you just follow it down. In this case, you knew the Y value. And so now you follow it down to find what X value. And so it's 70 grams of sugar. And it says, what tends to happen to the number of calories as the number of grams of sugar increases? Well, if you look at the graph, as the sugar goes up, the points rise. And so that means as the sugar increases, the calories increase. So I'm going to say, as the number of grams of sugar increase, the calories increase. We want to be specific on these. We don't want to just write goes up or something. We want to be specific. Okay, it says another point 55 to 80 is plotted on the graph. Explain the meaning of this point. Well, 55 is X, and that was grams of sugar, and 280 is Y, and that was calories. So it means that there is a smoothie that has 55 grams of sugar and 280 calories. Okay, so let's talk about the word correlation. Correlation is the relationship between the data sets. So like what you see in this first graph here is that the points are fairly close together and they're slanting in a positive slope. So this shows a positive linear correlation. And the reason it's positive is because as the X is increasing, the Y is increasing. And so that has a positive slope. So if you look at this next one, it has a negative slope just because it slants down. And so as X is increasing, the Y values are decreasing. So as you move to the right, the Y values are getting smaller. This one has no correlation because the points show no pattern. Like if you look at them, they do not make any type of a pattern, any type of a line. They're just a very random scatter plot. And so that's why they have no correlation, is because they show no pattern. All right, this wants us to identify what we have here. So this does show a relation, and it's a fairly good one. And so we're going to say that it has a negative linear correlation because it does fall in mostly a line with a negative slope. So it has a negative linear, because it makes a line, correlation. And what the relationship is as the average temperature increases, the Y value, which is the number of coats sold, decreases. Okay, if you look at this next one, this one is just kind of random. It doesn't really form the path of a line. So it really doesn't have a correlation. And if you think about the situation, a person's age doesn't necessarily impact how many vehicles they own. Some people will keep a vehicle for a really long time. Some people change them all the time. But it doesn't necessarily change how many vehicles you own just because of how old you are. So number of vehicles owned doesn't depend on a person's age. Okay, and if you look at this one appears to be in a fairly, a fair line, like a little bit of a curve, but mostly a line. And it's definitely slanting up, so it's a positive linear correlation. And what that tells me is that as the speed increases, as the x values increase, so the faster you're going, the distance to stop also increases. So what that means is the faster you're going, the longer it takes your car to come to a stop. Okay, now we're going to learn how to make a line of fit. And so a line of fit, you make a scatter plot of your data. You decide if it looks like the data fall in somewhat of a line. And if they do, you draw a line that appears to fit the data closely. It says there should be about as many points above the line as below it. It does not have to go through any data points. It can, but it doesn't have to. So this is the part people struggle with. You write an equation using 2 points on the line. Those 2 points don't necessarily have to be actual data points. They can just be points off the line. Okay, so what I'm going to go ahead and have you do is I'm going to have you make a scatter plot of our data over here to the right. So I'm just going to show you so we all set it up the same. Let's go ahead and go by ones. So 2, 3, 4, 5, 6, 7, 8, 9, 10. And then on the y-axis, let's go by tens because we need to go decently high here. And so when you're setting up, do this as 10, 20, 30, 40, 50, 60, 70, 80, 90, and then 100. Whoops. Make that 90. And this is the year. Since 2010. And this is the subscribers. And it's in millions. So when they say 10, they mean 10 million. All right, I'm going to pause the video. What I want you to do is I want you to put the scatter plot points on here. So for example, 09 is right here. 121 is right here. Just go ahead and pause the video real quick and fill this in so that you can pay attention when we move on. Okay, so we've got all of our points plotted on here. And so if you look at the steps, step 1 was make a scatter plot of the data. Step 2 is can it be modeled by a line, which yeah, they mostly fall in a line. Step 3 is draw a line that appears to fit the data. And it does not necessarily have to go through any points. It can go through whatever points it needs to, but it doesn't necessarily have to. So you need to use a ruler to do this or a straight edge of some kind. I'm going to kind of cheat and use this tool on my calculator or on my computer. And so what I'm trying to do here is I'm trying to have about as many points above the line as below the line. So I feel like that looks fairly in between. I'm trying, when I look at it, to think about having, 4 points above and 4 points below about. I'm not going to get there perfectly, but fairly close. So that's going to be my line. Yours may be in a different place, and that's completely okay. So like we're going to have close answers, but if we all have the same answer, like when we're doing, something on a review or a worksheet, then it's really going to be kind of questionable. So I look for points actually on the line. So like, for example, this point right here is the point 6 and then 65. And so that's not an original data point, but it is on the line, and so I'm going to use that. So I'm just choosing points off where I think they go through. I'm getting as close as possible. It's not perfect, but as close as possible. I also feel like right here, it goes through 0, 10. Once again, that wasn't an original point, but it will work for what we're doing. So I'm going to go ahead and find my slope, and my slope is 65 minus and 10, because I do y2 minus y1 over x2 minus x1. So I end up getting 65 minus 10 is 55, 6 minus 0 is 6. And so then we can do that in a calculator. We can do 55 divided by 6. And so when it's a word problem, we may not use a perfect slope. That's totally fine. It just happens. So then I'm going to do y minus, I'm going to use this point right here. I'm going to use 65 equals 9.2 times x minus 6. I distribute the slope. We learned how to do this earlier in this chapter. 9.2 times negative 6 is negative 55.2. And then I'm going to add the 65 over. And we can come up with slightly different things. If you had your line in a slightly different place, that's totally okay. It absolutely happens. Even on my original notes I did for this example, I had my line slightly different. And it definitely came out just slightly off of where I'm at right here. Okay, so I had this as my line. So fairly close over here. And so what that's giving me is it says, write an equation that models the total number of subscribers. Okay, so I did that. And interpret the slope and the y-intercept. Okay. Sorry, this should be a plus, I believe. All right, so what the slope is when I try to interpret the slope, I think about it as y over x. And so 9.2 is the y, which is millions of subscribers, and x is the year since 2010. So what this tells me is that the website gains 9.2 million subscribers every year after 2010. All right, and what the y-intercept tells me, the y-intercept being 9.8, tells me in the initial year, which was 2010, there were about 9.8 million subscribers on this website. So the y-intercept is telling me the starting amount. In this case, it was in 2010, but it's telling me the initial amount of subscribers. And so when they interpret, we want to be really, really specific.